Since the dawn of his creation, man has gazed with wonder at the nighttime sky, staring at the mysterious points of light and luminous moon as they cross the heavens, made him consider his own existence and formed within him a basic curiosity of life that is still with us today. These shiny, bright dots in the sky were beyond early man's experience. He could not feel them, hold them, taste them, or even see them very clearly. The stars must be the eyes of God, he thought, or diamonds that shone through the dark shell of night, and the moon must have been a servant sent by God, a servant that alternately comforted him, controlled him, and at times tormented him at will. This huge sky, virtually misunderstood by mankind, instilled fear in many early societies. It was said, and is still believed today, that the movements of the stars controlled our destinies. Such is the philosophy of the pseudoscience known as astrology. Ancient peoples, having been successful on a given hunt, let's say, were told to thank their lucky stars and so forth. As civilization progressed, so did man's thirst for knowledge of the universe above him. Stars began to be classified into groups known as constellations. And later, those stars that were observed wandering across the sky in set patterns were dubbed planets, which quite literally means wandering stars. And as these planets were discovered, they were given names, generally chosen from Greek or Roman mythology. Mercury, the messenger of the gods, the closest planet to the sun and one of the smallest. Venus, the goddess of beauty, the second planet from the sun, nearly identical to Earth in many ways. It was believed that Venus was inhabited by legions of people who lived in luxury amidst a tropical paradise. Mars, the god of war, the fourth planet from the sun, known as the red planet, its color clearly visible from Earth. Mars is very similar to Earth, and at one point in its history had flowing rivers of water running across its surface. Jupiter, named after the most powerful Roman god, is the fifth farthest planet from the sun, but it is by far the largest, being equal to the mass of 1,000 planets the size of Earth. Saturn, the sixth planet, orbits the sun only once every 29 years. Hence, the ancients named it after Kronos, the god of time. When people think of a planet besides Earth, they most often think of Saturn, due to its extensive ring structure made up of billions of chunks of ice and rock. Uranus, named for Urania, the mythical Greek astronomer, was unknown to ancient man. Too far distant from the Earth to be seen with the naked eye, the seventh planet from the sun has proven to be one of the oddest, in that many of its attributes seem to contradict known laws of physics and motion. It possesses a ring system much like Saturn, but it is less spectacular. Neptune, named for the Greek god of the sea, is very much still shrouded in mystery. Undiscovered until 1846, Neptune, like Uranus, is made up almost entirely of liquid gases and ice, with the possibility of a solid core. Its bluish-green color is due to the high amounts of methane gas in its atmosphere. Pluto, the ninth and farthest planet from the sun, was not discovered until 1930 by a young astronomer named Clyde Tombaugh. It is by far the smallest of the planets, only about 800 miles across, and is composed mostly of methane ice. It is so far away that the Sun appears as no more than a merely bright star when viewed from the planet's surface. As cold as deep space can be, Pluto is appropriately named after the god of the underworld, the god of an ice-cold hell 3 billion kilometers from the Sun. From the outset, man's study of the universe around him became a matter of practical importance. Firstly, to allay the basic fear of the unknown, and secondly, to better comprehend his place in the great scheme of things, a study which continues today. One thing the early study of the constellations revealed to us was that from our observations of the stars and our accurate charting of their positions, they would tell us where we were at any given point on the surface of our planet. Ancient mariners, indeed some societies, still use the stars to navigate the vast oceans that cover 2/3 of the Earth's surface. You see, it's very simple, as are many things that are seemingly difficult to comprehend. The position of the stars in the Milky Way are relatively constant to one another. In actuality, they, like our own Sun, are orbiting the center of the galaxy. But as it takes 200 million years for one such orbit, it can be said that in our short span of observation, they barely move a whisker. Anyway, once the ancient mariners had determined the position of the stars in the sky and accurately cataloged them, they were able to determine to a fair degree their own position on the Earth by simply looking up in the sky and gauging the change of the stars' so-called fixed positions. But what does all this have to do with the planets? To understand our curiosity and our unceasing study of the planets, we must look to how mankind utilized his knowledge of the motions of the bodies above him. For in many ways, by studying the planets, we can glimpse not only into our Earth's past, but maybe its future as well. Space travel, though commenced just in the last 30 years, is not a new idea. In fact, Johannes Kepler wrote in a work entitled Somnium of a trip to the moon, and he did so in 1634. Interestingly, Kepler's hero used demons to transport him to the surface of the moon, which to Kepler was remarkably similar to Earth, only that it was ruled by barbarians. Unlike modern times, grandiose ideas of this sort were not immediately put into practical operation. It took 300 years for man to develop the machines that would take him into space. Though we found no barbarians on the moon, in many ways our advances in the technology to achieve spaceflight arose from civilization's conflicts with barbarians of its own making, most notably Adolf Hitler and World War II. By the start of World War II, modern design rockets had already been developed and tested. In fact, the first launch of a liquid-fueled rocket had taken place on March 16, 1926. An American scientist, Robert Goddard, was the first man to create a rocket capable of sustained, controlled flight. Of course, this first rocket streaked into the sky for a total flight time of 2½ seconds. But it was a start. But the German government during the war undertook one of the most impressive technological development programs in history, all with one purpose: the creation of sophisticated weaponry to ensure German domination of the entire European continent, if not the world. Among such advances as the jet aircraft, the German scientists invented the infamous V-2 rocket, which they utilized to rain down destruction on the whole of England until the defeat of Germany in 1945. However, before succumbing to a monumental concerted effort on the part of the Western Alliance, they managed to design and build a two-stage liquid-propelled rocket, the precursor of our own modern-day launch vehicles. The defeat of Germany and Japan in World War II left the United States as the world's most dominant power, and hence the country best suited to further development of rocket technology. The first rockets developed for spaceflight suffered many fatal flaws and were doomed to destruction on the launch pads. This happened time and time again until significant problems in design and quality control were worked out and the United States space program began in earnest. Like the ancient mariners who set sail for uncharted and undiscovered lands, we too have sent our own mechanical missionaries into the outer reaches of the space frontier. So far, one of those missionaries, Voyager 1, has left the known solar system and now flies at 35,000 miles per hour into deep space. It carries on it a message from its maker to anyone who may come across it in the millions of years ahead. Its message is encoded into a gold record which says very simply, "Hello, this is who we are, this is where we are from, and this is what we sound like." Imagine an intelligent life form billions of years from now believing, as many of our species do, that life only occurred on his planet in his solar system, coming across this obvious and literate example of a life form from a place light years away. He will know then that he is not alone. But what have we learned about our own planetary system in the last 30 years? What are the other planets like, and will we ever be able to inhabit them? The answers lie in many a dark and mysterious locale, some more visible and known than others, but all most certainly hostile to man. In many ways, the search for these answers began here, in the clean room of the Jet Propulsion Laboratory in Pasadena. It is here that our probes, man's messengers, if you will, are built and tested. The closest planet to the Sun, Mercury, understandably possesses one of the harshest and most variable environments. Hot enough to melt lead and boil sulfur during its long day, then as cold as space itself at night. Viewed from the planet's surface, the Sun would be a huge boiling mass that fills 2/3 of the sky. Of course, while one might stand on the surface of Mercury, at least the night side, should you do so during the day, you would be reduced to a pile of ashes within seconds. Not a very nice place.
Because Mercury has no atmosphere, things are very different there. We find enormous differences in day and nighttime temperature. And for us human beings, the problem is that it's always either too hot or too cold. So the place where human beings would probably start to explore Mercury would be in the twilight zone, in the zone between day and night.
A little more than 1/3 the size of Earth, Mercury nonetheless is a rather heavy planet. Its composition is very similar to Earth's, in that both have a core that is made up of iron. Mercury is in a virtual vacuum. There is no atmosphere surrounding the planet whatsoever. A planet this small has a rather difficult time holding on to any kind of atmosphere due to its low gravity. The air just floats away out into space.
The big thing that we don't know about Mercury is that we don't know whether there's a lot of volcanism there or not. I mean, what we see on Mercury is we see craters and we see intercrater plains. Now, it may be that those intercrater plains are volcanic, but that's about all you can say mineralogically.
But there is a second reason for Mercury's emptiness, the heat. Any gases present in the early history of its formation have long since boiled off by now. Whatever gas was present in Mercury's interior rocks is now far off into space. Perhaps some of it has floated north of the Earth to be inhaled by some living creature, maybe one of us, breathing deep that single molecule of hydrogen that escaped from such a lonely place billions of years ago. Mercury looks very similar to the Moon in that it is extremely pockmarked by craters that have not eroded away. Huge valleys and mountain ranges on the surface seem to indicate that at one time Mercury was alive with volcanoes, much as Earth was, except that evidence shows that the core of Mercury has cooled down now to a mostly solid mass. As it does so, it becomes denser and smaller. Thus, Mercury, the second smallest planet in our solar system, is gradually shrinking. Imagine, if you will, a planet that circles the Sun once every 88 days. A planet whose surface temperature during the day is over 900 degrees, and at night to some 400 degrees below zero. A planet where salt and lead would boil away during the day, and where the breath you exhale would freeze into ice at night. This is the forbidding harshness of the closest planet to the Sun. This is a day in the life of Mercury. The second planet from the Sun is Venus, named for the Greek goddess of beauty. As you will see, this planet is anything but beautiful. No other planet has captured man's attention and imagination like Venus. You see, Venus is about the same size as Earth, has about the same mass, the same gravity, but is totally shrouded in clouds. Early astronomers, seeing the pattern of clouds change but never seeing beneath them, began to imagine marvelous things about what kind of world must exist beneath those clouds. Based upon their own knowledge of Earth, it was assumed that any planet shrouded in total cloud cover must be very moist and swamp-like. And since we all know how swamps are packed with living organisms, everything from leeches to crocodiles, Venus must be brimming with huge, bizarre, wet monsters. And yes, maybe a tribe or two of Venusian wild women. As crazy as that may sound, those theories existed within the scientific community up to the early 1960s. Well, to be honest, most serious scientists always held doubts as to the existence of the Venusian wild women. Well, the truth has been discovered about Venus and its nature, and it is far from pleasant. Several probes, launched by both the United States and the Soviet Union, have landed on the surface of Venus, beaming up detailed information of the planet's atmosphere during the slow descent. In 1975, the Soviet Union, after previous mixed success in landing a probe on Venus, launched the Venera 9 and 10 spacecraft. Designed to land on the surface, they were packed with scientific instruments to measure and analyze the atmosphere, record temperatures, atmospheric pressures, and equipped with 2 cameras to radio back the first pictures from the surface of the planet. What the Venera landers discovered upon their entry into the atmosphere laid to rest any hope of finding life as we know it on Venus. The beautiful, graceful mist-like clouds are made up of tiny droplets of battery acid, sulfuric acid to be precise.
The atmosphere is very corrosive, I'm sure. The atmosphere on Venus mostly consists of carbon dioxide with sulfuric acid. Well, I mean, we all know that sulfuric acid is not particularly healthy for living beings. Carbon dioxide is not too bad, except there's no oxygen. And so the lack of oxygen would be another thing that you'd have to deal with.
Beneath this stinging layer of acid clouds lies a lower atmosphere made up principally of carbon dioxide and nitrogen, what we commonly call smog, but without any oxygen. As the Venera landers descended further, they began recording both higher temperatures and higher pressures, ever increasing, in fact, until at the surface, a pressure of over 1,300 pounds per square inch is exerted upon everything at a temperature of over 900 degrees Fahrenheit. In other words, even though nearly identical in size, weight, and gravity to Earth, should you be suddenly transported from the comfort of your living room to the surface of Venus, you would be instantly hammered flat by the pressure, mere microseconds before you were incinerated into a pile of ashes. So much for the Venusian wild women. While you can't go to Venus, you can see pictures that were made of its surface. Thanks to lenses made out of diamonds as big as quarters, the Soviet cameras aboard the Venera landers were able to withstand the heat and pressure for a time and return these pictures of the planet's surface. A surface so forbidding that equipment made out of diamonds and titanium and cooled with liquid nitrogen survived only 35 minutes on the surface before going dead.
Of all the planets that we've been to, Venus is probably the least hospitable. Now, that's due primarily to 2 things, the temperature and the pressure. The pressure is about 100 times the pressure on Earth, and the temperature is as high as 700 degrees Fahrenheit. So to stand on Venus and to look around would be very difficult for a human being to last very long. When the Soviet probes landed on Venus, they didn't last very long either. If you look at a picture of what the Soviet probes look like, you can tell what they were designed to protect against. They look like huge boilers. A boiler is built to contain pressure. The boilers that the Soviets sent to Venus were built to resist it. And what 90% probability made these landers fail when they did was the extreme pressure and the extreme temperature.
There is a very important reason for us to study the environment on Venus. It is far and away the best, or possibly the worst, example of what has been termed the runaway greenhouse effect. The theory behind it is very simple. but has drastic implications for the Earth and life as we know it. All planets are to some degree heated by the sun. This heat radiation is called infrared. It is the same radiation that comes from electric heaters, toasters, and our bodies. Some of the sunlight that strikes a planet is reflected off of the atmosphere and back out into space. Some is absorbed by the atmosphere, and some is transmitted to the ground. On the ground, the sunlight warms the rocks and dirt, which release heat or infrared radiation. Once again, some of this is absorbed by the atmosphere, some is reflected back to the ground, and some is transmitted back into space. On Earth, this works in total harmony. Just enough sunlight is absorbed by the ground to maintain temperatures in which all living organisms can survive. The rest is reflected back up into space. The exact same thing occurs on all planets with atmospheres to one degree or another. Now that is where we start to make comparisons between the Earth and Venus. Our planet contains virtually the same amount of carbon dioxide as Venus, except that 90% of the CO2 is still found in the crust of the Earth. Whereas on Venus, almost all of the CO2 is found in the atmosphere. As the sunlight passes through the atmosphere and strikes the ground absorbs the radiation that heats up. This releases more CO2 from the rock to the air. When the infrared radiation is reflected off of the ground, it should pass unhindered back out into space. But the more CO2 in the atmosphere, the more of that heat will be bounced back to the planet's surface to further heat the ground, thus beginning a cycle where more CO2 is released into the air to reflect more heat back to the surface, and so on, until what you have is a planet which is unable to release any of the heat that it receives, and thus becomes an image of burning hell.
It's a human problem. That is, if you could stop everybody in the Earth from burning fossil fuels tomorrow, then you could probably do something about it. But the reality is we can't just be geophysicists anymore. We've got to consider the human element, and the human element says that it'll be hundreds of years before we can stop people from burning fossil fuels. And we're going to load the atmosphere with carbon dioxide, come hell or high water. And the hell part will get there first.
Another related issue on our own planet, equally important as the runaway greenhouse effect, is the protection of our safeguard, if you will, known as the ozone layer. The Earth possesses a layer of ozone in its outer atmosphere that effectively blocks the majority of ultraviolet radiation that would normally pass through to the surface. This keeps the plants and animals from being fried to death. And because it keeps plants alive, they continue to absorb sunlight. This keeps Earth relatively warm. And maintaining planet warmth is equally important to keeping it cool. Another ice age could be devastating to our species. But in the last few years, a dramatic change has been noted in this ozone layer. It seems as though a hole has appeared in the ozone layer above Antarctica. This hole fluctuates in size, but it has become increasingly larger as the years have progressed. Should this layer of ozone dissipate, life on this planet would surely meet a very dismal end. A theory has been proposed as explanation for this phenomenon, and it involves the widespread use of aerosols in our society, most notably chlorofluorocarbons, often known by the trade name Freon. Freon is used in countless applications in our society. It cools our refrigerators and freezers. It cools our offices and cars. It propels our antiperspirants and hairsprays. It also destroys ozone. So on one hand, we have a world filled with people using an agent which is known to destroy ozone, that remarkable layer which enables our lives to continue. And on the other hand, we continue to burn fossil fuels in our factories and our automobiles, the exhaust of which is primarily CO2. Not only are we contributing to an increase of the surface temperature, which results in more carbon dioxide being released from the rocks, but we are directly adding CO2 to the atmosphere as well. Where will it end? As yet, no one knows. One thing remains clear. Our environment on this planet is very tenuous indeed. Should a greenhouse effect get started on Earth, there is no way we could stop it. Within a few thousand years, the temperature and pressure on the surface would become so oppressive that all life would end. Now, as the most intelligent creatures on this planet, it is our duty to see to it that that does not happen. To a point, we are truly masters of the Earth's destiny. to a point.